So let's see, 2.1 addition and subtraction of integers. You can see some of the types of problems that they're giving here. So that won't be too difficult. I'm gonna guess that after dealing with some of the problems that you had on the exam, these are going to be a whole lot easier, right? So if we look at just the types of problems that are on here, you can see negative value minus a negative, negative or positive minus a negative value, negative plus a negative. How do we handle all of these different things? So it's going by some of the problems that are on there. Like if we have, say, 3 plus 2, hopefully everyone realizes that's 5, right? If I say 3 minus 2, that's going to give us a 1. But if I try to trick you and say 3 minus a positive 2, should be able to look at that. Negative times a positive is going to give you negative. So that just ends up being 3 minus 2. So we know what that's going to be. If I say 3 plus negative 2, again, positive times a negative is going to give us a negative. So again, this is going to be 3 minus 2. And then if we do 3 minus a negative 2, negative times negative is going to give us a positive. Which is just going to be the thing that's on the top there. Now, I will say one of the biggest issues that students have in the next class up is remembering if you have a negative times a positive, positive times a negative, those are going to give you negatives. Negative times a negative, that gives you a positive. That's like the number one mistake that the students make in the next class up. And when I was talking with my students about that, I told them last time when I got the faculty evaluation, one of the students complained to me, dude, you told us negative times negative is a positive like 100 times. We didn't get it the first time. We're not going to get it the 100th time. Just stop and move on. It's like, well, I thought I did it 200 times. And again, what was the biggest mistake that they would make? This negative times a negative thing. If we have, let's say, a negative 3 plus a 2, if you don't like having that negative out in front, you can actually rewrite these like that. So maybe that'll uh, help you try to figure out what's going on. But the way that we can think about this is you've got, say, $2 in your checking account, but you go and you spend $3 on a coffee. How much do you have in your checking account after that? Well, you're going to be overdrawn by $1. And then, depending on what bank you have, they might charge you an overdraft fee. But the basic idea here is that you can end up with a negative number like this. And one of the really, really weird things about numbers like, say, -1 and the -3 that I've got here, if you go back far enough in time and you talk, and let's say you're able to talk with some of the great philosophers you might learn about in your philosophy class, even if they were great mathematicians for their time, and you talk with them about negative numbers or even the number zero, they're going to get really, really mad at you because they don't believe those exist. Uh, One of the reasons is if you have zero, what does zero mean? There's nothing. But from their understanding, zero means there's nothing. But God is everywhere. And you're saying that there's nothing there, so there's no God there because zero means nothing. Therefore, zero cannot exist. And these negative numbers, those are even more controversial because you're saying, you mean there's less than nothing? Yeah, yes, there is. And if again, since God is everywhere, how can how can you have nothing there or less than nothing there? Therefore, negative numbers don't exist. Therefore, most of the math that we're going to do today does not exist. Wouldn't it be nice for all of you if that was actually true? But what you have to keep in mind is we're dealing with the interpretation of what do these actually mean. So you spend $3, but you only had two. So say you had to borrow $1. And does anyone like borrowing money? Probably not. So we can think of that as a negative if we want to look at it that way. We can work with some of these. So I can write out something like this. Negative times a positive is going to give us a negative. So I have -3 minus 2 equals -5. Again, I can just even have here, say -3 plus a -2. Positive times a negative is going to be a negative. So we're still going to be getting the same number. If I do -3 minus a -2, negative times a negative is a positive. That's going to give us -3 plus 2, which is basically what we had right there. So there are a lot of different ways we can try to write these out. We can try to trick you with these. A couple of things to keep in mind. Let's say you're doing the homework on these, and you're trying to do this problem right here, or something like it, and you're using a graphing calculator. On the homework, you're allowed to use calculators of all kinds. It's just on the exam, you're not allowed to. To get the negative right there, to get these negatives that are right here, and all over the place over here, if you're using a TI 83 or 84, the buttons you need to push if you want to do a problem like say -3 uh, plus a -2, what you have to do is you can't hit the minus sign. You have to hit the negate button, 3, and then hit the plus button, then hit the negate button again. If you type in the minus sign in both of those places, your calculator is going to give you an error. Now, if you're using your cell phone to try to do these, I don't think Apple phones require you to put the negate sign out in front. You can just go ahead and use the minus sign. So it can be a little bit tricky if you're going from one type of a calculator to another, but eventually you can actually get the correct answer here, or at least hopefully. And if you look at what it says up here, we can visualize addition as moving to the blank on the number line. So we're talking about addition. So if we're adding things, we're adding to the right side. And if we're subtracting, we're going to the left. So if we look at something like this 5 minus a negative 2, we'll do a different problem than that. So if we say 4 minus a negative 2, and we've got our number line. So let's say right here is a 0. Right here is a 4. So with subtraction, it's telling us to move that way. But we have to move negative 2 spaces that way, which means we actually go the opposite direction 2 spaces. So this actually becomes 4 plus 2, which is equal to 6. So you can think of like the negate right here, or the negative, as telling you to do the opposite. So it's the negative says move to the left. This says do the opposite 2 spaces. It's kind of weird to think about it like that, but that is one way that you can do it. Uh, so here's the example problem. I have 3 oranges and my wife has some pears. If we have 9 pieces of fruit, how many pears does my wife have? So that's getting into the types of problems that we've got down here. And just looking at some of the problems that are a little bit further along. Has anyone heard of someone talk about comparing apples and oranges? So in the case of the problem that's right there, let's say I have uh, 4 oranges, and then we have uh, 10 pieces of fruit. I ask the question, how much fruit do you have? Well, there's how much I have plus how much you have is how much we have. I have 4 plus whatever you have gives us 10. Since I'm adding 4 here, to figure out what u is, I have to do the opposite, so I have to subtract 4. So the amount of fruit that you have is going to be equal to 10 minus 4, which is going to be equal to 6. So looking at this, because the problem is talking about pieces of fruit, I think I spelled that wrong, but you know what? I don't care. Uh, we can actually add things and subtract things together like that. Now, if I said I have 4 oranges and we have 10 pieces of fruit, how many oranges do we have? What's the answer to that? I don't know. What type of fruit do you have? We've got at least 4, right? Could there be more? Yeah. Could there be less? No. Unless you have a piece of fruit that will somehow turn an orange into something else. We have at least 4. So we have to be careful of the wording that we're dealing with. So if you look at the example problem that's here, so if like later tonight when I'm at a bar, someone comes in and they have 2 dogs and someone else brings in 3 dogs, how many dogs are there? 5. Easy enough, right? Uh, but if you look at B, it says 4 elephants plus 3 giraffes. Uh, if you talk about animals, I could say we have 7 animals because 4 plus 3 is 7. But if I have to specify elephants and giraffes and everything else, then there's nothing I can do there, okay? So we have to look at what type of question is being asked, how are they asking it, and then go from there. So again, if you want to know how many dogs or how many animals we have here, dogs are animals, right? So you can just add them together, no big deal. Here, if we want to know how many animals do we have, we can say 7. But if we're supposed to keep it as elephants and giraffes, can you add elephants and giraffes? Oh, you can put them in the zoo, right? So you can say if you have 4 elephants and 3 giraffes, what does that equal? A zoo. And go from there. If we're looking at say problem here, because we've got x and x here, they're the same. So we can add them together and get 12x. But if you look down here, 4x plus 3y, again, we have to ask the question, what do x and y represent? If x and y are just variables like they are there, then you can't really add them together. But if I say, if we go someplace and we're trying to say buy stuff for brunch or something like that, and I get say 4 croissants and you get 9 donuts, and I ask how many pastries do we have? Well, donuts and croissants are both pastries, so now we can add them together and come up with a different number. So we do have to watch what it is we're actually trying to combine. What is the outcome that they are asking of us? Because there are some trick questions like that that will come up. If you look at the quarters and dimes things, are quarters different than dimes? If I gave you a choice of a stack of quarters that was that big or a stack of dimes that big, what would you rather have? Rather have the quarters, right? Because if nothing else, you can take them and go play pinball someplace, right? But sometimes we can take things that are different like this and actually convert them into something else. So instead of quarters and dimes, talk about pennies. How many pennies go into a quarter? How much is a quarter worth? 25 cents. How much is a penny worth? 1 cent. So how many pennies go into a quarter? 25. A dime is worth 10 cents. We can convert it, go from dimes to pennies. and say 10 pennies. And then even though those are two different denominations of money, we can still add them together because they have an actual relationship. So if we have a problem, uh, so 3/4 and 5 dimes. So 3/4 and 5 dimes. We know that a quarter is equal to 0.25 of a dollar, or that a quarter is equal to 25 pennies, plus 5 times 1/10 of a dollar, because that's what a dime is, or plus 5 times 10 pennies. If we do it this way, 3 times 25, 75, plus 5 times 10 is 50. So we can say we end up with 125, and in this case, pennies. We can convert that to dollars and say we have $1.25. Now, going along those same lines, or same thought process there, do you know what a loonie and a toonie is? Canadian $1 bill, or Canadian $1 coin, Canadian $2 coin. So if you know that a loonie is worth $1 Canadian, and we have one of them, plus $2 Canadian. 1 times 1 is $1 Canadian. And then 2 times 2 is $4 Canadian. So again, depending on the type of money that we're dealing with, uh, there might be some common thing that goes into there. And if I have, say, one Susan B. Anthony dollar coin plus 2 toonies. So this is American money, that's Canadian money. What do I need to do in that case if I want to add them together? I have to go and convert it, right? If I say something like $1 Canadian is equal to 70 cents US, I can use that conversion up here. And we would end up with $1 from here plus 2 of these toonies, which are $2 Canadian, but use the conversion factor here. To say we have to multiply this by 0.70 US divided by $1 Canadian. Is this getting to be a bit of a mess here? Yeah. But 1 plus 2 times 2 times 0.7. So 2 times 2 is 4. 4 times 0.7. This whole thing ends up being what? $2.80 US? Because what's 4 times 7? 28, right? Well, we're doing this times 0.7, so it's 2.8. So again, with some of these problems, you have to be able to look at them and recognize that there might be some other unit that we can convert them to. If we can, then we need to do that. So it says here you can only ever add things that are the same thing. And when you add the same things, you get the same thing. So again, up here, these are both animals. So again, if I said how many animals do we have, you add these together. If I asked you, if I gave you this problem here and asked you how many dogs do we have, how many dogs do we have in that problem? None. So that could easily be another trick question that they would want to ask you. And looking at some of these problems here, 9 plus 0. So you have $9 in your wallet. You go through the entire day without spending any money. How much money do you have left in your wallet? $9. You have nothing in your wallet, but you have to borrow $3. How much do you have left? That's going to give you a -3. You have $5 in your wallet, but you spend $5. How much do you have left? 0. So sometimes these make some sense, sometimes not so much. I'm looking at these. It says add and subtract fractions and decimals. What do we have to keep in mind when we're adding and subtracting fractions? When we go to look at all these, we need to make sure what we have a common denominator. So this works, that works. Not so much here. Not so much here, not so much here, not so much here. But we can come up with a common denominator for some of these. So if I have a problem like that, couple, there are actually 3 different ways that we can try to solve this one, okay? So I know this will be long and boring, but hey, this is math. You should be used to it by now. So I will say this first one is the no clue method. You have no idea what's going on here. This is literally the most generic way of doing this. So you look at these and you don't see any common denominators that you can come up with. If you do, we'll talk about that in a moment, but just looking what we have here, let's say you don't see that. First step is to multiply the other fraction by whatever the denominator is of the first fraction. 10 times 10, that's going to be 100. 25 times 10, that's going to be 250. 4 times 25, that's going to be 100. 10 times 25 is the same as 25 times 10. So that's also going to be 250. Once we have the common denominator, we can actually combine them like that. That's going to give us 100 plus 100. So that's 200 over 250. But if this is a problem on the exam, what do we have to do here? We have to come up with the reduced fraction here. Can I divide the top by 10? Can I divide the bottom by 10? Yes, I can. So first step, divide both of those by 10. That's going to give me 20 over 25. Can I, top number here is even, the bottom number is odd, so I can't pull out a 2. 2 plus 0 is 2. 2 divided by 3 does not give me, or I have a remainder. So it's not divisible by 3. This isn't divisible by 2. It's definitely not divisible by 4. So it doesn't matter what the top is here. Can I pull a 5 out of each of these? So divide top and bottom by 5. And we can get 4/5. If we have some clue about what's going on here, okay? And again, if you already see how to do this and what's going to happen, awesome. If you don't, well, this is why we're doing it a couple different ways. So if you have some clue about what's going on here, I can ask the question, uh, 25 times what gives me 10? There isn't a nice number there. 10 times what gives me 25? Well, it's going to be 2.5. Do we like dealing with 2.5? Probably not. So what's a common value that that I can multiply something over here by to get a multiple of a value over here? So what are multiples of 10? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What are multiples of 25? 25, 50, 75, 100. What's the first number that I said that was exactly the same between those two? 50. If you didn't hear me say 50 for both of them, you should have heard me say 100 for both of them. Both of those ideas would actually work. But if we decide that it's going to be 50, 25 times what gives me 50? So that's going to be a 2. And then on the other side, I have 4 times 10. 10 times what gives me 50? So that's going to be a 5. So 20 or 10 times 2 is 20. 25 times 2 is 50. 4 times 5 is 20. 10 times 5 is 50. Now that we have the same denominator, I can again come in here and rewrite it like that. So that's going to give me 40 out of 50. And then I have to reduce this. I've got a 0 here, I've got a 0 here. Can I divide both these by 10? Absolutely. So did I just save myself some math if I have some clue about what's going on here, right? Uh, so if you have a big clue about what's going on here. First step is actually going to be what? Look at the numbers I've got up here and reduce them to begin with. Can I pull a 5 out of 10? Can I pull a 5 out of 25? Absolutely. Can I pull a 2 out of 4? Can I pull a 2 out of 10? Absolutely. 10 divided by 5 is 2. 25 divided by 5 is going to be 5. 4 divided by 2 is 2. 10 divided by 2 is going to be 5. Now that we've got the same common denominator, so if we're trying to come up with a way to, to work these problems, okay? So if you're looking for like, say, step-by-step procedure, step one should always be looking at, can you reduce anything that you're starting with? And then once you've reduced it, then you move on to whatever we have over, or this method over here, where you can just cross multiply everything. So if we look at some of the example problems that we've got here, can we reduce that? No. Can we reduce that? No. So we can cross multiply, work with that. Or we can look at this and say, hey, maybe, just maybe, there's a common denominator that, or a common factor between these two that we can look at. You look at these, uh, is there any way to reduce it? No. But can I multiply 4 by something to give me 8? So multiply the bottom by 2, multiply the top by 2, and we're done. Looking at what I have over here, can I reduce that at all? No. Can I reduce that? Well, that's even, that's even. I can at least get rid of a 2, right? So, uh, in keeping with uh D, in keeping with the ideas that we've been talking about here, can I reduce this at all? No. So that's going to move on just the way it is. Can I reduce this at all? Well, even number and an even number, so I can at least pull a 2 out of these. Can I pull even more out of these? Yeah. So and if you've ever taken a class where you're working on problems like this before, this is basically the thought process that your teacher had. So 8 divided by 4 is going to give me 2 on the top. 12 divided by 4, that's going to give me 3. Now I can look at this. 9 times what gives me 3? A third. 9 times a third. Since that's a fraction, don't want to deal with that. Can I say 3 times something gives me 9? Yeah. Multiply the denominator by 3, multiply the numerator by 3. So now I've got 5 over 9 plus 2 times 3 is 6. 3 times 3 is 9. Because I now have a common denominator, I can keep it like that. 5 plus 6 gives me 11 over 9. If we're supposed to reduce this, how many nines are there in 11? There's only one. Then I have two left over. Nine divided by nine, it's going to be one. So my reduced, like, final answer, if this happened to be a problem on the exam or problem on the homework, would be that 1 2/9. So I can see if there's something else we can work on here. So with these two, they've got the common denominator, just add across the top, common denominator, add across the top. So looking at the 9 and the 12 here, there's nothing that we can really reduce, but we can come up with the common factor between them. So do another one of these. So if I've got 2/9 plus 5/12, again, we've got two different ways we can do this. If we don't know any better, so again, if we have no clue, just take the denominator from the other side, multiply it across. Two times 12 is 24. 9 times 12 is what? 90. 9 times 11 is 99. So 9 times 12 has to be 99 plus 9. So 108. 4 or 5 times 9, it's going to be 45 over 108. We can now add these together. 45 plus 24, or sorry, add those together. 45 plus 4, that's 9. 4 plus 2, and now we have to look at that and ask ourselves, can we reduce that any further? And because you all so totally remember the rules that I was saying about uh, figuring out if it's divisible by 3, we add the two numbers together and then try to divide that by 3. What's 6 plus 9? 15. Is 15 divisible by 3? So I can pull a 3 out of there. 1 plus 0 plus 8, that gives us 9. Is 9 divisible by 3? Yep. So we can at least pull a 3 out of each one of these. So if you're trying to figure this out, this is where you have to start doing it longhand. How many times does 3 go into 6? So it's going to be a 0. Bring down the 9. How many times does 3 go into 9? 3 times. So on the top here, I'm going to have 23. And then if I do 108 divided by 3, how many times does 3 go to 1? None. How many times does 3 go into 10? 3 times, but there's going to be one remainder. Bring down the 18. How many times does 3 go into 18? So is that a really, really ugly problem? Yeah. So what is another way that we can do it? Well, if we start thinking about what are multiples of 9, 9 plus 9 is 18. Add 9, 27. Add 9, 36. Add 9, 45. Add 9, 54. Add 9, 63, and so on. The 12 over here, what value are you gonna, or what are we gonna get from that? Well, it's gonna be, uh, 12 plus 12 is 24, plus another 12 is 36. I already said 9 plus 9 plus 9 plus 9 is 36, so we've got a common factor there. Looking at these as well, we can break these down. And I have no idea how much this is actually going to help anyone, so I'm just trying to be honest about it here. So 3 times 3 is 9, 4 times 3 is 12. If we want a common denominator, we'll take everything that's in one of these denominators and then multiply it by the stuff that's different on the other side over here. 3 times 3 is 9 times 4, 36. So that's where that denominator comes from. Again, I'm not sure if that actually helps out. Not really. More confusing. So again, if you have no clue what to do, just cross multiply everything. If you see here that there might actually have a common denominator that's not the cross multiple, that is a lot better option. So again, if you remember your multiples of 9, 9 times 4 is going to be 36. And then 12 times what gives you 36? So we look at that, 2 times 4, 8 over 36 plus 15 over 36. 8 plus 15 over 36. So that's your 23 over 36. So a lot of different ways we can do these. Step one for all of these should always, always, always be looking at them and asking, can I reduce them? If you can, awesome. For some of these, you can look at them and say, 4 times what gives me 8? So I'd multiply the top by 2, the bottom by 2. Common denominator that way. Here I'm looking at it, 3 times what gives me 5? Not a happy number. 5 times what gives me 3? Again, not a happy number. So cross multiply them. Here I noticed that there's a 3 that's involved in at least both of these, so there should be a common multiple. But sometimes getting to that common multiple can be a huge pain in the butt. Now, if we're looking at some numbers like these, it says line up the decimal places and add accordingly. And notice that it says here, add accordingly, and then what does it give you here? a minus sign. What does it give you here? A minus sign. So what is that trying to tell you? Subtraction is just addition, but you're adding a negative number. Does that help out at all? Probably not. But if we've got something like um, so if we happen to have something like this, sometimes it helps to write or rewrite things. Again, we've got to make sure that our decimal lines up. Since there are 3 decimal places here and only 2 here, I put the extra 0 at the end. If I wanted to, I could put a whole bunch more zeros on here, and that's not going to affect anything. 4 plus 0 is 4. 1 plus 1 is 2. 5 plus 3 is 8. 3 plus 2 is 5. We have to remember the decimal point there. If I say 3.514 minus 2.31, again, I have to line up the decimals. So what am I going to get here? 4 minus 0 is what? 1 minus 1. 5 minus 3. 3 minus 2. And if I do this, like that, how do we handle that one? I mean, other than looking at it and pulling out a calculator or crying, what do we do? 0 minus 4, we can't do that. So I have to borrow 1 from here to give me 10. So now I've got 10 minus 4. That's going to be 6. 0 minus 1, I can't do that. So I have to borrow 1 from here. So now I have 10 minus 1, which is going to be 9. 2 minus 5, can't do that. So I have to borrow 1 from here. So that's going to give me what? So 12 minus 5 is 7, and then 1 minus 3. Can't really do that, so that's going to be -2. And that just looks horrific, doesn't it? Did I even do that one right? A lot of borrowing, a lot of carrying. And when you're done with it, it looks really, really horrific. And is it even more horrific than that? So 2.31 minus 3.5, using what, 514? Uh-oh, what happened? So what happened here? It's horrible, isn't it? So It's easy to start looking at these and actually get a wrong answer. If you start working on it the wrong way, what do we actually need to do here? And if you notice, it's actually what? Just the opposite value of what we had here. So what looked easier to do? This problem over here or this problem over here? The one on the left or the one on the right? Which one looked easier? So if we switch the order of these things, we should just be able to switch the sign here. So is there a lesson in here for us? I mean, other than we hate subtracting numbers like these, right? So what should we really be doing here? Just recognize that whatever we get here, it's going to be the opposite of it because we're taking small minus big instead of the big minus small. So rewrite every mixed number as a fraction. All right. Then we start adding some of these mixed numbers. And again, what do we do if we have fractions? We have to come up with common denominators. So if I have 4 and 1/5, uh, and I need to write that as an improper fraction, I'm going to take whatever's out in front, multiply it by the denominator, and add whatever's on the top. Then divide all of that by 5. So 4 times 5 is 20. 20 plus 1, it's going to give us 21 over 5. If I have 3 and 8/9, again, 3 times 9 plus 8 over 9. 3 times 9 is 27. So 27 plus 8 is what? So if I have a negative 4 and 7/10, again, there's going to be the negative, but this negative applies to everything on here. So I'm going to have 4 times 10 plus 7 divided by 10. So negative 4 times 10, 40 plus 7 divided by 10, 40 plus 7. It's going to give me 47. I have to remember to keep the negative there the whole time. And then I get negative 47/10. So now, based on all this and based on some of the problems that we have, if I had, let's say, 4 and 7/10 minus 4 and 1/5, what are we going to do here? Well, we already know that negative 4 and 7/10 is going to turn into this. So I make it positive here, I make it positive here. I already know that this whole thing is going to turn into that. What's our next step? We have to come up with a common denominator. 10 times what gives me 5? I got nothing. 5 times what gives me 10? So 5 times 2 is 10. 21 times 2 is 42. So we now have 47 over 10 minus 42 over 10. Now that we've got the same common denominator, 47 minus 42 is 5. 5, and then that's going to be divided by 10. Can I simplify 5 divided by 10? Can I pull a 5 out of each one of those? Yeah. So eventually, I get my 1/2. And let's see. Yeah, that's pretty much everything here. And to do 2 more of these. So again, if we're going to add these together or subtract these, we have to turn these into improper fractions. So I'm going to have 2 times 4 plus 1 over 4. And then here I'm going to have 1 times 9 plus 5 over 9. 2 times 4 is 8. 8 plus 1 is 9 over 4. 1 times 9 is 9. 9 plus 5 is 14 over 9. Is there any common denominator that you can see instantly between these two? Absolutely not. So we're just going to cross multiply. Actually, is there? Yeah. But if you don't see it, you have to go about it the long way. Actually, in this one, this is going to be the smallest denominator. So 9 times 9 is 81. 4 times 9 is 36. 14 times 4, well, 14 times 2 is 28. 28 plus 28. Now that the denominators are the same. So it's 81 plus 56. Well, 1 plus 6, that's 7. 8 plus 5 is 13. Now, if I have to go, now if I'm allowed to leave it as an improper fraction like that, awesome. If not, what's my next step going to be? I have to come in here and break this down as say 36 plus 36 plus 36 plus some other number, or whatever the remainder is, divided by 36. How come I wrote 36 down here 3 times? 1 plus 2 is going to be 3. So there's at least a 3 in there. So 36 plus 36 plus 36 is what? I mean, other than a complete mess. Since you're probably not going to have a problem like, or that's this horrible on the exam, you can actually grab our graphing calculator. And I'll just say 137 minus 36 minus 36 minus 36. So I've got nothing going there. So that's going to be 29 on the top. And eventually this whole thing gives us the really, really ugly number of 3 and 29/36. That's a bit. Up here, if we're doing the same thing, first up, we have to make sure that these are improper fractions. So 4 times 5 plus 3 over 5 minus 2 times 7 plus 2 over 7. 4 times 5 is 20. 20 plus 3, 23/5. 2 times 4 is 14. 14 plus 2, 16 over 7. Is there a common denominator we can get here? Again, no. So we multiply by the denominator on the other side. Uh, 5 times 7 is going to be 35. 23 times 7. Anybody remember those multiple tables? So I've got to do what? 23 times 7. So it's 161. And then on the other side, 16 times 5. Since you're not allowed to use a graphing or use a calculator on the exams, how would you have to do those? Well, 2 times 7 is 14 plus 2 is 16. There you go. 3 times 7 is 21. So 1 carry the 2, blah, blah, blah. And then with 16 times 5, 5 times 6, 30. So 0, carry the 3. 5 times 1 is 5. 5 plus 3 is 8. Now that we're at this point, though, if I just had this as 160 minus 80, I'd get 80. So that's actually going to give me 81/35. 35 plus 35 is 70. 81 minus 70 is going to give me 11. So are we starting to hate these yet? They're horrible, right? Uh, so do one last example and then I'll let all of you try to figure or work on these. So looking at the fraction here, can I reduce that at all? No. Looking at the fraction over here, can I reduce that at all? Yes, I can. So we will do this two different ways. Again, assuming that you have no clue what's going on here. You don't see any of this stuff. Then we'll look at it, what happens if you do. So if we have no clue what's going on, first step, take whatever's here, multiply it by that, add it to the denominator. Same thing over here. So 1 times 4 is 4, 4 plus 3 is 7. So this becomes 7 over 4. Plus over here, 2 times 8, 16, 16 plus 4, that's going to be 20. Looking at the denominators, are they the same? Absolutely not. Uh, can I multiply 4 by something to give me 8? Yeah. Add the tops together. 14 plus 20. It's going to give us 34 over 8. I can divide at least these numbers by 2, right? Now that I've got it to 17 over 4, can I reduce that even any further? Well, 17 is a prime number, so there are no more factors here. So we're kind of stuck. So now we do 4 plus 4 plus 4 plus 4 plus 1. Where did all that come from? 4 plus 4 plus 4 plus 4 is 16. 16 plus 1 is 17. Why do I have the 4's here? Because I got a 4 in the denominator here. If we do see something here and we do see that you can reduce this, can I pull a 2 out of here? Can I pull a 2 out of here? Yeah. Now, if you're really smart, you looked at that and said 4 divided by 8, dude, that should be 1/2, right? You all saw that? Why did I only pull the 2 out? Now I've got the correct denominator there, go into there. So again, if you see it, you can make things a whole lot easier on yourself. So if you're if you're really smart about these, you can actually get rid of a lot of the steps that we just had in there, right? If you went all the way and reduced this to 1/2, you'd still end up doing the same thing. The difference is you'd have a 4 over here, you'd have a 2 over here. 2 times what gives you 4, so you multiply whatever's on top by 2, whatever's on the bottom by 2. You get your 10/4, and then 1. So again, these are just to say, if you have no idea what you're doing, can you still get the right answer? Yes. But if you see something, you might be able to do it a little bit sooner and end up doing a whole lot less work. So again, looking at these, which method do you guys like better? Having no clue, doing this entire thing, doing all these steps, or maybe spotting something at the beginning, save ourselves some work. And remember, the less work that you have to do, the less chance you have of making a mistake. The less work you have to do, the quicker you can get the problem done. So you can go faster and get more points. Yay, right? Isn't that what we all want? So, and when you guys were, or when you were all working on these types of problems, say back in high school, did any of your high school teachers explain any of this stuff like that? Or did they just do it the quickest way and then go, and see, now we're done? And then you look at it and go, huh? What? Where'd that come from? Really? So I know it's boring trying to do the same problem 2, 3, 4 times in a row. But again, if you see how to do it faster, that's awesome. If there is no way to do it faster, well, that's a thing. So I'll just give you that problem to work on. So what's going to be the first step with both of these? Turn it into an improper fraction. Step 2 is going to be common denominator. What do you think the common denominator is going to be here? 10. Which means you multiply the denominator here by what value? 2. So when you've got this change, multiply the numerator by that same value. So you think you got it then?
You think I got them? I just started.
Yeah.
Thought you were done before you were done.
Yeah.
Hmm.
So the way that and I see what you're trying to do here, but the way that I'm looking at it going from here to here, I'm seeing this is 69 counts and then this is also 69 counts.
Wait, stop. Do
Yeah,
you want me to write it down?
it's fine. But for the exams, all right. And I will be working on grading your exams tomorrow. So you should have those by the end of the day tomorrow. So
You did.
you got the right idea. Um, so initially they shoot time plus three, and then 14 spot. And then on one side it's over 12, on the other side it's over 5. And so you need to reduce that. So what's the next step?
Back and then. I'll figure that out.
You got the right idea. You're correct up to that point. So you're both correct up to that point. You just need to go that one extra step. Cool. Actually. So you need to go one extra step to turn them into a mixed number. So
Mixed number matrix.
yeah. So you got the right idea. You are correct up to that point. You need to go one extra step. So initially you got 23 over 10 plus 23. That should be over 5. And then when we combine them, multiply the top and the bottom by 2. So yeah. I got it.
Yeah, mentioned like weekly. Part of the campus, because we need, where I do love to.
I'd have to look back. I'll check in my computer in a moment. See what I can come up with. And yeah.